When you picture Antarctica, what strikes you as most remarkable? Perhaps the fact that it contains 70% of Earth's fresh water locked in ice, or maybe that beneath its frozen surface lies an entire hidden world. But what if I told you that Antarctica holds secrets far stranger than most imagine, including active volcanoes erupting through ice sheets and lakes that haven't seen daylight for millions of years? To many, Antarctica seems like Earth's most lifeless continent, a frozen void at the bottom of the world. However, that perception couldn't be more wrong, as Antarctica is actually teeming with mysteries and life, just not in the ways you might expect. While Antarctica appears desolate on the surface, what lies beneath tells a completely different story. Under the ice sheet, which averages 1.2 miles thick, exists a landscape more dramatic than the Alps, complete with mountain ranges, valleys, and canyon systems that dwarf the Grand Canyon. The Gamburtsev Mountains, for instance, are buried under 2 miles of ice, yet they rise to heights of 11,000 feet, comparable to the Rocky Mountains. These peaks have been entombed in ice for over 34 million years, perfectly preserved like a geological time capsule. Scientists only discovered them in 1958 using seismic equipment, and even now we know surprisingly little about these hidden giants. What makes them even more mysterious is that they shouldn't exist at all. Mountain ranges typically form at tectonic plate boundaries, but the Gamburtsevs sit in the middle of the Antarctic plate, far from any geological activity that could explain their formation. It's like finding the Himalayas in the middle of Kansas. Some geologists theorize they formed from multiple continental collisions. Others suggest they're remnants of ancient hotspot volcanism. But nobody really knows for certain how they got there, making them one of Earth's greatest geological mysteries. The bedrock beneath Antarctica tells stories of the supercontinent Gondwana, when Antarctica was connected to Australia, India, Africa, and South America. Fossil evidence shows that 250 million years ago, Antarctica was positioned much further north, creating conditions that supported vast coal swamps. Yes, coal in Antarctica, formed from ancient tropical forests. These coal deposits are extensive enough to power the world for centuries, though thankfully they remain untouched due to international treaties. The Transantarctic Mountains themselves hold countless secrets, stretching 2,200 miles across the continent, making them one of the longest mountain chains on Earth. These mountains contain fossilized forests from the Permian period, complete with tree trunks still standing in their original positions,
preserved so well you can count growth rings, telling us these trees experience seasonal changes, even though they were growing near the South Pole at the time. But coal isn't the only resource hidden beneath the ice. The Transantarctic Mountains contain iron ore deposits rivaling those of Western Australia, while the Antarctic Peninsula shows evidence of copper, gold, and silver. Even oil reserves likely exist in the continental shelf. Some estimates suggest 200 billion barrels of oil could be present, more than Saudi Arabia's proven reserves, making Antarctica potentially one of the most resource-rich continents on Earth, all locked away under miles of ice and protected by law. The Prince Charles Mountains contain deposits of rare earth elements, critical for modern electronics and renewable energy technology. These deposits formed when Antarctica was volcanically active, creating concentrations of minerals found nowhere else on Earth. The ice itself is a scientific goldmine of a different sort. Antarctic ice cores provide climate records stretching back 800,000 years. Each layer of ice captures atmospheric conditions from when it formed, including trapped air bubbles that are literal samples of ancient atmospheres. Scientists can measure prehistoric carbon dioxide levels from these bubbles, revealing that current CO2 levels are the highest in human history. The oldest ice ever found is 2.7 million years old, and scientists are actively searching for ice that's even older, because somewhere in Antarctica lies ice from before the Ice Age began, which could revolutionize our understanding of climate change. These ice cores also contain evidence of ancient volcanic eruptions, preserved as layers of volcanic ash from around the world, including the Toba supervolcano that nearly drove humans extinct, and mysterious eruptions that left no other trace. But here's where things get truly weird. Antarctica has liquid lakes beneath its ice sheet. Over 400 subglacial lakes have been discovered so far, with new ones being found every year using satellite technology. The largest, Lake Vostok, is the size of Lake Ontario, buried under 2.5 miles of solid ice. These lakes remain liquid due to geothermal heat from below and pressure from the ice above, which lowers the freezing point. Lake Vostok has been sealed off from the surface for 15 million years, making it one of the most isolated environments on Earth. The water in these lakes is under pressure equal to 350 atmospheres, similar to conditions in the deepest ocean trenches. When Russian scientists finally drilled into it in 2012, they found something extraordinary. Life. Not just microbes, but complex bacteria, unlike anything known to science.
These organisms survive in complete darkness under crushing pressure, in water that's below freezing but kept liquid by pressure. With no contact with the surface world for millions of years, they've evolved in total isolation, creating unique biochemistry. Some produce natural antifreeze proteins to survive. Others feed on minerals from the bedrock below, creating an ecosystem that shouldn't exist. DNA analysis revealed over 3,500 species in Lake Vostok, including bacteria that metabolize methane and sulfur, and others that seem to feed on the bedrock itself, dissolving minerals for energy in complete darkness. This discovery suggests life might survive in similar conditions elsewhere, like in the subsurface oceans of Jupiter's moon Europa or Saturn's moon Enceladus, making Antarctica a testing ground for astrobiology. Scientists now use Antarctica to develop techniques for detecting alien life, testing equipment that might one day drill through Europa's ice. The surface of Antarctica is equally bizarre. The dry valleys are the most Mars-like place on Earth. These valleys haven't seen rain for 2 million years, making them drier than the Sahara Desert. Yet somehow they're in Antarctica, surrounded by ice. The valleys remain ice-free due to katabatic winds, supercooled air that rushes down from the polar plateau, reaching speeds of 200 miles per hour. These winds evaporate any snow before it can accumulate, creating a frozen desert in the middle of Earth's iciest continent. The soil in the dry valleys contains perchlorate salts, the same chemicals found on Mars. NASA tests Mars rovers here because conditions are so similar, including temperature ranges that can swing 70 degrees in minutes. Yet even here, in Earth's closest approximation to Mars, life persists. Bacteria live inside rocks, surviving on trace amounts of moisture and obtaining energy from iron minerals in the stone. Some of these microbes divide only once every 100 years, living life in the ultimate slow lane. They've been there for millions of years, barely metabolizing, waiting out the ice age in biological suspended animation. These organisms might be Earth's oldest living things, with some colonies potentially millions of years old. Blood Falls in Taylor Valley is one of Antarctica's strangest features, a waterfall of blood-red liquid flowing from Taylor Glacier. The color comes from iron oxide, basically rust, but the source is a lake trapped under the glacier, 400 meters down. This lake is 3 times saltier than seawater and has been sealed off for 2 million years. Yet it contains a thriving ecosystem of bacteria that survive without oxygen or sunlight, using sulfate instead of oxygen for respiration and iron for energy in a process never seen before. Antarctica also hosts Earth's most extreme weather phenomena. Diamond dust ice crystals that form from clear air, creating sparkling curtains that fall from cloudless skies. These crystals can create halos, sundogs and light pillars, optical phenomena that make Antarctica look like an alien world. Sometimes creating triple suns or inverted rainbows, effects so bizarre early explorers thought they were hallucinating. In winter, temperatures at Vostok Station have reached minus 128.6 degrees Fahrenheit, the coldest temperature ever recorded on Earth's surface. But satellite data suggests even colder spots exist, with some high-altitude areas potentially reaching minus 144 degrees Fahrenheit. At these temperatures, carbon dioxide freezes out of the air, creating dry ice snow that falls like regular snow, except it sublimes directly back to gas, never melting. Steel becomes brittle as glass, and rubber shatters like ceramic. Human breath freezes instantly, creating ice fog that hangs in the air. Exposed skin can freeze in under 30 seconds, and frostbite can occur in less than 5 minutes. The aurora australis creates light shows that put the northern lights to shame. Because Antarctica's magnetic field anomaly makes auroras more intense, sometimes the entire sky erupts in ribbons of green, purple and red, visible even during the austral summer's 24-hour daylight. The South Atlantic anomaly causes additional electromagnetic phenomena, creating radio dead zones and compass failures, sometimes causing satellites to malfunction when passing overhead. Speaking of summer, Antarctica experiences the midnight sun, 4 months of continuous daylight at the South Pole, followed by 4 months of complete darkness, with brief twilight periods in between. This extreme photoperiod affects everything from algae growth to human psychology. Plants in Antarctic greenhouses grow faster under 24-hour light, but produce different chemical compounds than normal plants, some developing novel proteins never seen in temperate regions. Researchers stationed there often experience profound psychological changes, including altered sleep patterns, cognitive shifts, and even hallucinations. Some report feeling a presence watching them in the darkness, a phenomenon so common it has a name, the third man syndrome. Ernest Shackleton first documented this during his expedition, describing an invisible companion that helped guide his team to safety. Modern researchers report similar experiences during isolation, leading to studies on how extreme environments affect the brain.
Antarctica has active volcanoes buried beneath the ice. Mount Erebus is the southmost active volcano on Earth, continuously erupting since at least 1972. Spewing volcanic bombs and maintaining a permanent lava lake, one of only 5 persistent lava lakes on the planet. The volcano creates its own weather system, with steam clouds that freeze instantly into ice towers, creating formations that look like frozen tornadoes. Scientists recently discovered 91 additional volcanoes under the ice, making West Antarctica the largest volcanic region on Earth. If these volcanoes erupted, they could melt the ice sheet from below, potentially triggering catastrophic ice sheet collapse. Some show signs of recent activity detected through ice deformation. Antarctica's ice shelves are collapsing at unprecedented rates. The Larsen B ice shelf, which existed for 12,000 years, disintegrated in just 35 days in 2002, releasing 720 billion tons of ice into the ocean. The speed of collapse stunned scientists worldwide. Satellite images showed it shattering like a car windshield, breaking into thousands of icebergs in mere weeks. Ice shelves act as plugs, holding back glacial flow. When they collapse, glaciers accelerate toward the sea. The Pine Island Glacier is now moving 40% faster than in 1970s, dumping 45 billion tons of ice into the ocean annually.
The Thwaites Glacier, nicknamed the Doomsday Glacier, is currently collapsing. This single glacier could raise global sea levels by 2 feet, and its collapse could destabilize the entire West Antarctic ice sheet, which contains enough ice to raise seas by 11 feet globally, potentially displacing billions of people worldwide. Recent discoveries show Thwaites is melting faster than predicted, with warm water penetrating further under the glacier each year, creating a point of no return that may already be passed. Warm ocean water is eating away at ice shelves from below, creating massive caverns that weaken structural integrity. One cavity under Thwaite is 40 square miles and 1,000 feet tall, large enough to hold 14 billion tons of water. These caverns are impossible to detect from the surface, making ice shelf collapse unpredictable and sudden. Robotic submarines exploring these caverns find them growing rapidly, with some expanding by hundreds of feet annually. Antarctica influences global weather patterns more than any other continent. The Antarctic Circumpolar Current is the world's largest ocean current, moving 135 million cubic meters of water per second. That's 600 times the flow of the Amazon River. This current connects all major oceans and drives global circulation.
Without it, Europe would be as cold as Labrador, Canada, and tropical regions would be uninhabitably hot. The current also blocks warm water from reaching Antarctica. But climate change is weakening this protective barrier, allowing warm water to penetrate further south each year. Antarctica acts as Earth's air conditioner, absorbing heat and circulating cold. The continent reflects 90% of solar radiation back to space. This albedo effect helps regulate global temperature. But as ice melts and dark rock is exposed, more heat is absorbed, accelerating warming, creating a feedback loop that's difficult to stop. Scientists call this the ice albedo feedback, one of several tipping points in Earth's climate system. Antarctic krill, the foundation of the Southern Ocean food web, are declining. These tiny crustaceans support everything from fish to whales. A single blue whale can eat 4 tons of krill daily. The total biomass of Antarctic krill exceeds humans, making them one of the most abundant species on Earth. Yet, krill populations have dropped 80% since the 1970s due to warming waters and declining sea ice where they breed. Ocean acidification also prevents krill from forming shells properly. Without krill, the entire Antarctic ecosystem collapses, taking with it penguins, seals, whales, and countless seabirds. Commercial fishing fleets now target krill for fish farms, adding human pressure to an already stressed ecosystem, creating potential for complete ecological collapse. The Southern Ocean absorbs more carbon dioxide than any other ocean region, acting as a crucial carbon sink that slows climate change. But warming waters reduce CO2 absorption capacity, and acidification from absorbed CO2 threatens shell-forming organisms, creating another dangerous feedback loop. Recent studies show the Southern Ocean's absorption capacity declining, potentially turning it from carbon sink to carbon source, which would accelerate global warming dramatically. Antarctica holds evidence of mass extinctions and climate catastrophes. The Permian extinction evidence is preserved in Antarctic rocks, when 90% of marine species died 252 million years ago. Fossil layers show the complete collapse of ecosystems, followed by millions of years of recovery. These rocks serve as warnings about ecosystem fragility and how quickly things can go wrong. Similar extinction evidence appears in multiple Antarctic locations, including signs of asteroid impacts and volcanic catastrophes, each leaving distinct chemical signatures in the rocks. The Antarctic Treaty, signed in 1959, is humanity's most successful international agreement, designating Antarctica as a scientific preserve, banning military activities and mineral exploitation.
Antarctic sea spiders grow to enormous sizes, with leg spans reaching 25 inches across, an example of polar gigantism not fully understood. These creatures have no lungs or gills, breathing instead through their legs, with their intestines extending into each limb. Some Antarctic organisms can survive being frozen solid. Tardigrades can endure complete desiccation and freezing, then revive decades later when conditions improve. Antarctic nematodes do the same, entering cryptobiosis, a state between life and death that could last centuries. These abilities might hold keys to human life extension, or long-term space travel requiring suspended animation. Some Antarctic fish can survive with 40% of their body water frozen, coming back to life when thawed with no apparent damage. Scientists study these mechanisms for human cryonics applications. Emperor penguins endure the harshest breeding conditions on Earth. Males incubate eggs through the Antarctic winter. Antarctica isn't just ice and penguins, it's Earth's last frontier, and perhaps our most important one. Because what happens in Antarctica doesn't stay in Antarctica. It affects every living thing on this planet, from the weather patterns that bring rain to your home, to the sea levels that determine where we can live, to the very stability of our global climate system. The secrets locked in Antarctic ice might save us, or the melting of that ice might doom us. Either way, Antarctica holds our future in its frozen grip. Thanks for watching, and until next time.